Ever found yourself staring up at the night sky, mesmerized by the dancing colors of the northern lights, and wondered what causes this spectacular phenomenon? It is indeed a sight to behold, and it's no surprise that it has captivated the attention of humans for centuries. The northern lights, also known as Aurora Borealis, are an enigmatic spectacle that has sparked curiosity and wonder since time immemorial. This breathtaking display of nature's power and beauty paints the sky with a palette of vibrant colors, creating a celestial performance that leaves viewers in awe. These mysterious lights have been the subject of lore and legend among different cultures. For instance, in Norse mythology, the lights were believed to be the glow from the shields and armor of the Valkyries, warrior maidens who carried fallen warriors to Valhalla. In Finnish folklore, it was thought that a mystical Arctic fox was swishing its tail across the snow, spraying it up into the sky to create the lights. Indigenous cultures in North America, on the other hand, considered them to be the spirits of their ancestors dancing in the sky. These interpretations, though varied, share a common thread: an attempt to explain the unexplainable, to make sense of the magical light show unfolding in the heavens above. But as enchanting as these tales are, they only scratch the surface of the true wonder that is the northern lights. This phenomenon is not merely a feast for the eyes, it's a complex interplay of particles and magnetic fields, a cosmic ballet that is as fascinating as it is beautiful. As we delve deeper into the study of these lights, we'll uncover the science behind their existence, exploring how the sun, the Earth's magnetic field, and the atmosphere come together to create this extraordinary spectacle. We'll journey from the realms of myth and folklore into the world of science, where fact and fantasy intertwine, and the truth is often more wondrous than fiction. Are these ethereal lights just a feast for the eyes, or is there a deeper scientific explanation? Stick around to find out. The northern lights are not just random illuminations in the sky, they're the result of a fascinating interplay between the sun and our planet. At the heart of this cosmic spectacle lies the sun. This fiery celestial body is constantly churning out streams of charged particles known as the solar wind. This solar wind travels across space at mind-boggling speeds, and some of it eventually finds its way to our planet. Now, Earth, like a superhero with a force field, is surrounded by a magnetic field. This magnetic field acts as a shield, protecting us from most of the solar wind. But the field isn't uniform, it's weaker at the poles, and this is where the magic happens. As the solar wind reaches Earth, the charged particles are drawn towards the poles by the magnetic field. They spiral down, gaining speed, and as they collide with atoms and molecules in our atmosphere, they transfer their energy to these particles, causing them to glow. This is what creates the stunning light show we know as the Northern Lights, or Aurora Borealis. But what about the different colors? Well, that's down to the Earth's atmosphere. The atmosphere is a mix of different gases, primarily nitrogen and oxygen. When the solar particles hit these gases, they cause them to emit light of different colors. Oxygen, for instance, gives off a greenish glow, which is the most common color of the northern lights. Nitrogen, on the other hand, produces blue or purplish red light. The altitude at which these collisions occur also plays a part in determining the color. Lower altitudes, where there's more oxygen, tend to produce green lights. Higher up, where nitrogen is more prevalent, you'll see red, violet, and occasionally blue lights. So the next time you gaze at the northern lights, you'll know you're witnessing a cosmic ballet of solar particles and Earth's magnetic field. Scene script. Have you ever wondered why the northern lights display a variety of colors? The northern lights, also known as the Aurora Borealis, paint the sky with an array of colors, from soft pinks to vibrant greens to deep purples. But this isn't just nature's own light show. Rather, these colors are a result of fascinating scientific processes happening miles above us in our very own atmosphere. Let's delve into how it works. The sun is constantly throwing out particles, which we call the solar wind. Now, when this solar wind reaches our Earth, it collides with the gas particles in our atmosphere. This collision excites the gas particles, and when they return to their normal state, they emit light. Voila! We have the northern lights. But why the different colors? Well, it's all about the type of gas particles involved and the altitude at which the collision occurs. The most common color, a bright yellowish green, is produced by oxygen molecules located about 60 miles above Earth. Rare, all-red auroras are also produced by high-altitude oxygen at heights of up to 200 miles. Meanwhile, nitrogen produces blue or purplish red aurora. The altitude plays a significant role too. Lower altitude collisions, around 60 miles high, tend to result in green colors, while higher altitude collisions, around 200 miles high, generate red. The blue and purple hues are usually at the lower edge of the aurora, caused by collisions at the highest altitudes. So, you see, the northern lights are not just a random spectacle of colors. They are a cosmic dance, a visual symphony that tells a story of the interplay between the sun and our planet. And each color is a note in that symphony. A note that tells us about the type of gas and the altitude of the collision. So the color palette of the northern lights is not just splendid to look at, but it also tells us a lot about what's happening high above in our atmosphere. Did you know that the northern lights aren't exclusive to the northern hemisphere? That's right, these celestial ballets of light aren't just a northern spectacle. They're a global phenomenon that graces both ends of our Earth. For those of you who might not be aware, the southern hemisphere has its own version of the northern lights, known as the southern lights or Aurora Australis. They occur when solar particles collide with atmospheric gases near the South Pole, creating a dazzling display of lights that mirror their northern counterparts. If you've ever wondered where and when you can witness these magical light shows, you'll be glad to know that they're not as elusive as you might think. You can see the northern lights in several countries stretching across the northern hemisphere. From the frost-kissed landscapes of Canada and Russia, to the Nordic wonderlands of Norway, Sweden, and Finland, these lights paint the night sky with their radiant hues. Even places like Scotland and northern parts of the United States like Alaska and Michigan occasionally get to enjoy this spectacle. The best time to see them? That's typically during the winter months when the nights are longer and the sky is darker. Heading south, you can catch the southern lights in the Antarctic regions, and sometimes even as far north as Tasmania and New Zealand. Again, the best time to see them is during the winter months, but remember, winter in the southern hemisphere is from June to August. But no matter where you are in the world, witnessing the northern or southern lights is contingent upon a few factors. You need clear dark skies, minimal light pollution, and of course, a bit of luck. Solar activity which causes these lights is unpredictable, so there's always an element of chance involved. So whether you're in the northern or the southern hemisphere, under the right conditions, you too can witness this awe-inspiring spectacle. Now that we've taken a closer look at the northern lights, let's summarize what we've learned. In our journey of discovery, we've explored the science that brings the northern lights, also known as Aurora Borealis, to life. We've learned that these lights are not just a beautiful spectacle, but a cosmic ballet of charged particles from the sun interacting with Earth's magnetic field. These particles, carried by solar winds, collide with the atoms in our atmosphere, causing them to glow and create the spectacle we know as the northern lights. We've also delved into the mystery behind the different colors of the northern lights. The variety of hues dancing in the night sky is not just a random occurrence, but a direct consequence of the types of gas particles involved in these celestial collisions. Oxygen atoms, for instance, give off a green or red light, while nitrogen produces blue or purple. The altitude at which these collisions occur also plays a part in the color display, with the green lights typically appearing about 60 miles above the Earth and red above that. But the northern lights are not confined to the north alone. We've learned that they are visible in several parts of the world, and their southern counterpart, the Aurora Australis, can be witnessed in the southern hemisphere. These lights are best seen in high-latitude regions such as Norway, Canada, Alaska, and Antarctica, where the magnetic fields are stronger. We've also learned that the intensity of these lights is not constant but varies depending on solar activity. The more active the sun, the more spectacular the display. So, catching a glimpse of this otherworldly spectacle requires a bit of luck and timing. So, the next time you see the northern lights dancing in the sky, you'll appreciate not just their beauty, but also the fascinating science behind them.